So I'll be going over question 7 from the week 1 worksheet. It asks you to think about the spontaneity of a reaction in terms of the Gibbs free energy equation. And then it asks you to consider several examples. So first let's write down the Gibbs free energy equation. Delta G is equal to delta H minus T delta S. So this is your enthalpy term, temperature term, entropy term. The first example is an explosion. This one is pretty simple because we already know the answer, that an explosion is spontaneous. If you've ever seen one or seen something burn, you know it's going to be spontaneous. You know it releases heat. That's a negative delta H. Temperature is always going to be positive because we're dealing with the Kelvin scale. And entropy is going to be positive. If you think about it, you're taking a solid or liquid fuel and you're burning it, it's going to become CO2, a gas, and water, either a liquid or a gas. So you're going to have a positive entropy. More states are possible. So an explosion is spontaneous. The next example asks us to consider this reaction, water being split into hydrogen and oxygen. So if you've ever seen hydrogen burn, that would be going this way. Hydrogen and oxygen combining to form water. That's a spontaneous reaction, similar to our example here, the burning or the explosion. But now we're going the opposite way. So again, we already know the answer up front, that this is non-spontaneous because we're adding heat in to the reaction and we're turning these gases, which are random, into liquid, which is much more ordered. So why would this ever happen? Well, this reaction is a lot of times called electrolysis or electrohydrolysis because you use electricity in order to drive it. So you put your electrodes in the water and it won't, one electrode you'll get hydrogen and the other one you'll get oxygen. So you're actually using the power of the electricity to drive this reaction, similar to how you would charge a battery. You're storing energy in these chemical bonds, chemical potential energy, which you can think of fairly similar to any other type of potential energy. Carrying a heavy rock up a hill is difficult, but kicking it down the hill is very easy. So this is carrying the energy up into a high energy state, and then when you light it on fire, it all goes this way very quickly, very easily.